Good morning, guys. I hope you had a nice Easter break and that we are ready to get back to work. So today's going to be a pretty easy day. All we're going to be doing today is going over the set of exercises that I gave you to complete last Wednesday. So if you have your exercises out and your textbook open, you can find these exercises on page 346. And for the set of exercises that I gave you, it's number 31, and then numbers 32 to 46 evens. So let's go ahead and go over those. Now, the first question was sort of a word problem, but it was pretty easy. It was just like the one that I went over with you in the instructional video. Hopefully you watched that at least once, if not many times. But they give you a problem to where they also give you a graph, and they say that the entrance to a parking garage is represented by the dot. Now, this dot is a point that is on the y-axis. And they say that this point to the entrance of the parking garage will be perpendicular to the given line, which represents a street in front of the garage. So if we draw a line segment through that point, which is the entrance to the parking garage, to the street, that forms a right angle. And of course, we know when it forms right angles, they are perpendicular. And they ask us in this question to find the equation of that line. So the entrance of the garage to the street will be perpendicular, and to find the equation of this line, the first thing we need to know is what the slope of the line is that represents the street, because we know that lines that are perpendicular have slopes that are negative reciprocals of one another. So if we know the slope of the street, then we will also automatically know the slope of the line perpendicular to the street. So we can see there that Handel Street has a slope of negative 4/5. And you can determine this by picking 2 points and using rise over run, or you can use the slope formula. So now that we know the slope of the given line is negative 4/5, we now know the slope of the line that will be perpendicular to this line, and that will be negative or a positive 5/4 because they have to be negative reciprocals of one another. So if the given one is negative, our perpendicular line has to have a slope that is positive. So now that we have our slope of 5/4, we can use that slope with the given point, which is also the y-intercept, so that makes it very easy. So we see that the y-intercept, which is marked by the entrance to the garage, has the point 0, 1. So with the slope and with the y-intercept, all we have to do is substitute these values into the equation of a line, and we will use slope-intercept form, y equals mx plus b, and we get the equation y equals 5/4 x plus 1. And that's all you had to do. And the equation here represents the line that would be perpendicular to the street going through the entrance to the garage. All right, now let's look at questions 32 to 46 evens. Now, I think it's 32 to 38. They had the directions to where they gave you a pair of lines and they asked you to determine whether they were parallel, perpendicular, or neither. Now, in order to do this, you need to remember that parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of one another. So let's look at the first pair of lines that they give you. Now these lines are in slope-intercept form, so it's very easy for us to determine the slope. So the first equation, y equals 4x plus 3/4, that has a slope of 4. The second equation, y equals negative 1/4 x plus 4, that line has a slope that is negative 1/4. So all you have to do now is ask yourselves, are these the same slope? Which we can see they are not the same value, so that means that the lines are not parallel. Next, we have to ask ourselves if these slopes are negative reciprocals of one another. Well, one is positive, one is negative. That's good. And then if we take a 4, which is also 4 over 1, and we flip it, what do we get? Well, 4 over 1, when we flip it, we get 1/4. So 4 and negative 1/4 are negative reciprocals of one another, so that means that the lines are perpendicular. Let's look at 34. 34, we have lines y equals negative x plus 5, and we have y equals positive x plus 5. Again, these lines are given in slope-intercept form, so we can very easily pull the slopes out. The first equation has a slope of negative 1. The second equation has a slope of positive 1. Are these the same value? No, they are not. Are they negative reciprocals of one another? Yes, they are. So again, since these are negative reciprocals of one another, these lines are perpendicular. Let's look at question 36. Here we have two equations that are again given in slope-intercept form. The slope of the first line is 1/3. Now, they changed this up a little bit, probably to try and confuse you, and they put the x in the numerator where we normally see a number. But that doesn't mean anything. Typically, when it's out here off to the side, that still means that there is a 1 in front of that x. So the slope here is 1/3. And we come down to the second equation, and we can also see that the slope again is 1/3. So we ask ourselves, are the slopes equal? And yes, they are. And since the slopes are equal, that means the lines are parallel. Question 38. Now these two equations are not given in slope-intercept form like the last three are. These equations are given in standard form. So you cannot directly see the slope. So we have to rewrite the equations of these lines, put them in slope-intercept form, and then pull the slopes out. So let's do that. Here we have the equation 2x plus y equals 2. To get this into slope-intercept form, we simply need to subtract 2x from both sides. So when we subtract 2x from both sides, we end up with y equals negative 2x plus 2, and the slope is negative 2. Let's take the second equation. Just like the last one, we have to subtract 2x from both sides. So we get y equals negative 2x plus 5. Again, pull the slope out. The slope is negative 2. Compare the slopes now. Are the slopes the same? Yes, they are the same. That means that these lines are parallel. So very easy to do. You just have to make sure that the lines are in slope-intercept form first, pull out the slopes, and compare them. Let's look at the last set of exercises that I gave you. Question number 40. Now, perpendicular lines, question number 40 is a multiple choice question. They ask you here to determine which pair of lines is perpendicular. So perpendicular lines have negative reciprocal slopes. Now we can see that in each one of these, A, B, C, and D, all of these pairs of lines are in slope-intercept form. So if they wouldn't have given them to you in slope-intercept form, you would have had to put them in slope-intercept form first, but they did that for you. So it's very easy to see the slopes. And we can see in choice C that they are the only pair of equations that have negative reciprocal slopes. All right, 42, 46, and 48. They give you graphs of parallel lines or perpendicular lines, and they ask you to find the equations. So let's look at 42. Let's talk about, first of all, about the blue line. We have pulled the slope and determined the slope from lines for a long time now, so you should be pretty good at that. You can either use rise over run, find 2 points on your graph and do rise over run, or take those 2 points and substitute them into the slope formula. So I'm just simply going to use rise over run for all of these. So we can see that the slope here is negative 3, but where the line crosses the y-axis, which is your y-intercept, it isn't seen on the blue line. If you look closely at your graph, we don't see it. So we have to find it. So we can pick any point that is on that line that we are sure of to help us find that y-intercept. So I'm going to pick the point 1, 4. So we substitute that into slope-intercept form equation of a line. So y is a 4, and again, that comes from our point right here. And we have equals m. Well, m is our slope, so negative 3. And x is our x-coordinate, so we substitute a 1 in, and it comes from right here. So after we substitute the values in, then we simply have to solve for b. So negative 3 times 1 is negative 3, and then to get b by itself, we have to add 3 to both sides, so 4 plus 3 is 7. So your y-intercept is 7. If our graph would have been large enough, and that line, blue line, would have been long enough, it would have intersected at 7 on the y-axis. So take your slope, take your y-intercept, put it all together, and you get the equation y equals negative 3x plus 7. All right, let's look at the red line now. The red line, we have to find the slope again. Well, quickly ask yourselves, are these parallel lines or are they perpendicular lines? Well, we can see that these lines are perpendicular, so we know that the slopes are going to be negative reciprocals of one another. But if you're not sure, use rise over run, and you will see that you go up 2, and to the right 6, and when you reduce that, you get 1/3. So these two slopes are negative reciprocals of one another. That tells you that the lines are perpendicular, but we already knew they were perpendicular because we can see that little square where the lines intersect, meaning that they intersect at a 90-degree angle. So again, we don't know B, can't see B, so we have to pick a point off of that line. I'm going to choose to pick the point 1, -1. And we will substitute it again into the formula y equals mx plus b. So y, which is 1, equals m, which is our slope, 1/3, times our x coordinate, which is -1, plus b. Solve for b. So 1/3 times -1 is -1/3. We need to add 1/3 to both sides. So now we have 1 plus 1/3. We need to find a common denominator. Common denominator is 3, so 1 becomes 3/3. Plus 1/3. Now that we have a common denominator, we keep our denominator and add the numerators. 3 plus 1 is 4. So our y-intercept is 4/3. Now 4/3 is 1 and 1/3. So if you looked at your graph, ask yourself, does it appear that the graph crosses at 1 and 1/3? And you see that that is reasonable, so we know that we are correct. So all we have to do now is write the equation of our line. Y equals m, our slope is 1/3. X plus b, which is 4/3. Question 44. Here, let's look at the top line first. So we have our slope, which is 2/5, and we substitute that 2/5 into our equation, y equals mx plus b, and we also substitute in 1 point. Now that point we're going to substitute in is 1, 1. So we have y, which is 1, equals m, which is our slope, times x, which is 1, plus b. Simplify that and solve for b. 2/5 times 1 is 2/5. And then we have to subtract 2/5 from both sides. So 1 is 5/5 minus 2/5. 5 minus 2 gives us 3. So we subtracted our numerator and we keep our denominator, so we get 3/5 for b. So when we write the equation, it's y equals mx plus b, so y equals m, which is our slope, times x plus b, which is 3/5. So the equation of the top line is 3/5. Now we can very easily see that these lines are parallel, so that we know that when we go to find the equation of our bottom line, it is also going to have the slope of 2/5. So we pick our point, which is 3, -3. We substitute that into y equals mx plus b along with our slope, which is 2/5, and we do the exact same thing that we did up here to the top line. We have to multiply our m times our x, so 2 times 3 is 6. And remember, this 3 is over 1, so 5 times 1 is 5. So we have 6/5. So to get b by itself, we have to subtract 6/5 from both sides. So we have -3 minus 6/5. Just like above, we had to find a common denominator. Our common denominator is going to be 5. So if we multiply this denominator, which is a 1 times 5, we have to multiply the numerator by 5. And -3 times 5 is -15. Now that we have a common denominator, we keep our denominator and we subtract our numerators. So -15 minus 6 is -21. So our y-intercept is -21/5. And that's just a little bit less than -4. So does it appear on your graph that it crosses just below -4? And you'll see that it does. So we bring all of that together, and the equation of our bottom line is y equals 2/5 x minus 21/5. Alrighty, so let's look at number 46 now. All right, our blue line. We can see that the slope is 1. We rise 1, we go 1 to the right, very easy to see. And we also can see here that it crosses at the origin. Well, that makes our work really easy, because if it's crossing at the origin, that is also our y-intercept, which is the value of b. So we already know b for this one, and we don't have to find it. So we simply take our slope and our y-intercept and substitute them into y equals mx plus b. So we have y equals m, which there's a 1 there, but we don't write 1s, times x, plus b, which is 0, and we don't ever write 0 when we add or subtract. So the equation of the blue line is y equals x. Now let's look at the equation of the red line. Again, we can see here that these lines are perpendicular. So If the slope of the blue line is 1, the slope of the red line has to be -1. We can see that this red line crosses the y-axis at 0, 1, and we're very sure of that point, so we don't have to spend time finding b like we did in the last couple of problems. We already know the y-intercept. It is 0, 1. So, just like above, we can take our slope and our y-intercept and substitute it into the equation y equals mx plus b. So y equals m is -1, times x plus b, which b is a +1, so we get y equals -x plus 1. And that's it. So those were your exercises. Hopefully you checked them with yours, fixed any errors that you may or may not have made. If you have any questions about anything that we just looked at, please make sure that you leave me a comment or shoot me an email. Have a good day.